Good day, everyone. Today we'll discuss the bisection method. The bisection method is a method wherein the interval is always divided in half. If a function changes sign over an interval, the function value at the midpoint is evaluated. The location of the root is then determined as lying within the subinterval where the sign change occurs. The process is repeated to obtain refined estimates. Figure 2.1 shows the algorithm for the bisection method. Step 1. Choose lower x sub l and upper x sub u guesses for the root such that the function changes sign over the interval. This can be checked by ensuring that the product of f of x sub l and f of x sub u is less than 0. Step 2. An estimate of the root x sub r is determined by the formula x sub r is equal to x sub l plus x sub u divided by 2. And then step 3. Make the following evaluations to determine in which subinterval the root lies. A. If the product of f of x sub l and f of x sub r is less than 0, the root lies in the lower subinterval. Therefore, set x sub u is equal to x sub r and return to step 2. B. If the product of f of x sub l and f of x sub r is greater than 0, the root lies in the upper subinterval. Therefore, set x sub l is equal to x sub r and return to step 2. C. If the product of f of x sub l and f of x sub r is equal to 0, the root equals x sub r, and then terminate the computation. Example, use bisection method to obtain a root from the function f of x is equal to x cubed plus 4x squared minus 10. Then terminate the process if the absolute approximate error is less than or equal to 0.0001 and tabulate the results. For this solution, we assume that x sub l is 1 and x sub u is 2. And then evaluating for the functions, f of x sub l is equal to 1 cubed plus 4 times 1 squared minus 10. This is now equal to negative 5. And then f of x sub u is 2 cubed plus 4 times 2 squared minus 10 is equal to 14. As you can see, the sign changes between values of 1 and 2. So we can now use x sub l is equal to 1 and x sub u is equal to 2 as initial guesses. For the first iteration, we're going now to use x sub l is equal to 1 and x sub u is equal to 2. And then, as evaluated, f of x sub l is equal to negative 5 and f of x sub u is equal to 14. Evaluating for x sub r is equal to 1 plus 2 divided by 2 is equal to 1.5. And then f of x sub r is equal to 1.5 cubed plus 4 times 1.5 squared minus 10 is equal to 2.375. And then the product of f of x sub l and f of x sub r is now equal to negative 5 times 2.375. This is less than 0. Therefore, we set x sub u is equal to x sub r that's equal to 1.5. For the second iteration, we're going now to use the value x sub l is equal to 1 and x sub u is 1.5. And then we have f of x sub l is equal to negative 5 and the value of f of x sub u is equal to 2.375. Evaluating for the x sub r, that is 1 plus 1.5 divided by 2 is equal to 1.25. And then, since we have a previous approximate, we can solve now for the absolute approximate error. That is the absolute value of 1.25 minus 1.5. That's equal to 0.25. And then, f of x sub r is equal to 1.25 cubed plus 4 times 1.25 squared minus 10 is equal to negative 1.7969. And then, solving for the product of f of x sub L and f of x sub R, that's equal to negative 5 times negative 1.7969, which is greater than 0. Therefore, set x sub L is equal to x sub R, which is 1.25. Continuing on with the iteration, for the third iteration, we use the values x sub L is equal to 1.25 and x sub U is equal to 1.5. And f of x sub L is equal to negative 1.7969 and f of x sub U is equal to 2.375. Evaluating for x sub R, that is now 1.25 plus 1.5 divided by 2. This is equal to 1.375. Solving now for the absolute approximate error, that is equal to the absolute value of 1.375 minus 1.25, that is equal to 0.125. And then solving now for f of x sub R, that is equal to 1.375 cubed plus 4 times 1.375 squared minus 10 is equal to 0.1621. And then the product of f of x sub L and f of x sub R is equal to negative 1.7969 times 0.1621, which is less than 0. Therefore, we set x sub U is equal to x sub R is equal to 1.375. Since the absolute approximate error for the third iteration is 0.125, and we need to terminate the iteration process at an absolute approximate error of less than or equal to 0.0001, we still continue with the iterations. After 13 iterations, we can see that the root is 1.3652 and we have obtained the absolute approximate error of 0.0001. That ends our discussion on bisection method. Thank you.